everyone. I am Dr. Manoj Kumar Sharma, Associate Professor, ITS College of Pharmacy, Muradnagar. This is the lecture number 16 and this is a continuation of the parametric test and it is part 2. The subject is Biostatistics and Research Methodology, subject code is BP 801T. The branch is Bachelor in Pharmacy and the university is Dr. APJ Abdul Kalam Technical University. The topic for present lecture are pair t test and least significant difference. The first is paired t test. The pair t test, a pair t test is used to compare the two population mean where you have two samples in which observation in one sample can be paired with the observations in the other sample. So, in pair t test we have population means, two population means, but the observation of first population and the second are both sample in one sample and second sample are paired. That means, in pair t test generally we apply the same patients. That means, for example, जैसे अगर आप पेन रिडक्शन के लिए कोई ट्रीटमेंट करते हैं तो उसमें पहले आप उनका ट्रीटमेंट से पहले पेन चेक करेंगे और फिर ट्रीटमेंट के बाद. तो दैट मीन्स वी कलेक्ट द ऑब्जर्वेशंस फ्रॉम द same sample at 2 times pre and post. It means for both mean the subjects or patients are same. So, these are also called dependent t test or t test for two dependent groups. A comparison of two different methods of measurement or two different treatments where the measurement or treatment are applied on the same subject. Be remember, the subjects are same at both time. For example, pre-test and post-test sample in which a factor is measured before and after in an intervention. Second, comparison of pre-pain score and post-pain score during a treatment of pain reduction. So, as in both cases the observations are paired or you say the subjects are same, I again tell you this pair t test is also known as t test for two dependent groups or dependent t test. The steps for t tests are: suppose a sample of n subjects were given an antihypertensive drug and we want to check blood pressure before and after treatment. We want to find on the effectiveness of the treatment by comparing mean and post treatments. That means, we want to compare the mean of pre-treatment and mean of post treatment. And as we know, in null hypothesis we consider that there is no difference between the two means. So, the mean of pre and mean of post are equal. Simply you can say the difference between the mean of pre values and mean of post values is equal to 0. So, null hypothesis we consider that the mean of the differences of the pre and post value equal to 0. That means, there is no change from pre value to post intervention and the where d bar is the mean between pre and post value. So, we can say in null hypothesis there is no significant effect or there is no change from a standard or pre to post values. तो null hypothesis क्या हो गया? null hypothesis हो गया जो हमारी प्री वैल्यूज हैं और जो पोस्ट वैल्यूज हैं उनका हम एक पहले डिफरेंस कैलकुलेट करेंगे और जो डिफरेंस का मीन है हम कहेंगे कि ये डिफरेंस का मीन 0 के इक्वल है. दैट मीन्स कि कि प्री से पोस्ट में जो हमने ट्रीटमेंट अप्लाई किया उसमें कोई चेंज नहीं आया, ये हमारी नल हाइपोथेसिस होगी। सेकंड, अल्टरनेट हाइपोथेसिस। अल्टरनेट हाइपोथेसिस एच ए डी बार इज नॉट इक्वल टू 0, दैट मीन्स देर इज ए सिग्निफिकेंट चेंज फ्रॉम प्री टू पोस्ट वैल्यूज। दैट मीन्स कि ट्रीटमेंट जब हमने अप्लाई किया, इंटरवेंशन कोई दिया, तो उसमें जो प्री वैल्यूज़ थी और जो पोस्ट वैल्यूज हैं उनमें का जो डिफरेंस है वो सिग्निफिकेंट है, दैट मीन्स इट इज़ नॉट इक्वल टू 0। जैसे अगर मान लो हमने कोई पेन रिडक्शन के लिए कोई ड्रग दी है, तो पेन हमने मेजर किया बिफोर द ड्रग इंटरवेंशन, फिर हमने ड्रग दिया उनको, आफ्टर द ड्रग इंटरवेंशन वी मेजर द पेन, दिस इज कॉल्ड पोस्ट पेन, and we find a difference between all these observation, then the mean of, if this difference is equal to 0, then there is no significant difference, and for alternate hypothesis this difference mean of pain reduction is not equal to 0, then we say there is a significant difference. Third step for pair t test is level of significance, this is alpha percent and generally we take 5%, and for more precise we take 1% or 0.1%. The degree of freedom for pair t test is equal to n minus 1, where n is the number of observation and t test for paired sample, the test statistic t equal to, this is the formula for to t, this is t equal to d bar s by root n. As you know, this is the standard error s by root n, s is the standard deviation of the sample, n is the size of the sample and d bar is the mean of difference of pre and post values. So, this is the formula for t test, where d bar calculated by the summation d by n, summation d is the difference of the pre and post values. तो इसमें हमने क्या करते हैं, सबसे पहले d बार फाइंड करने के लिए आप समीशन d बाई n, और d क्या है, डिफरेंस बिटवीन द प्री एंड पोस्ट वैल्यूज. SED is the standard error of the difference and this will be equal to standard deviation upon square root of the sample size. Sample size is n and SD is the standard deviation of the sample and it can be calculated by standard deviation of the difference. Be remember, SD is the standard deviation of the difference. In this we find the standard deviation between pre and post values. First we find the difference between the pre and post values, then we find the standard deviation, and this standard deviation formula is summation d square minus summation d whole square upon n minus 1, where d is the difference between pre and post values. And the next term for t test is the degree of freedom, and degree of freedom will be n minus 1. After that, the last statistics apply the t test, we write the inference, and if the calculated value of t at a given level of significance alpha percent and degree of freedom is less than the tabulated value of t, then accept null hypothesis and no significant difference between the means of pre values and means of post values. तो अगर आप हमारी कैलकुलेटेड वैल्यू कम आ जाती है टेबुलेटेड से, देन वी से द मीन ऑफ प्री वैल्यूज इक्वल टू द मीन ऑफ पोस्ट वैल्यूज, और सिंपली यू कैन से there is no significant difference between the mean of pre values and post values. But if our calculated value is greater than the tabulated value, then we say the mean of pre values is not equal to the mean of post values, and we say there is a significant difference between the pre and post values. To understand this, we take example. In this example, data recorded on the rainfall of two places A and B in 10 years given below. Last 10 years में दो प्लेसेज हैं A एंड B, उन पर जो रेनफॉल हुआ वो इसमें गिवन है. 1971 में A प्लेस पर जो रेनफॉल हुआ वो हुआ 177.29 मिलीमीटर, while rainfall in place B is 69.79 millimeter. In 1972 we have 146.12 and in B 103.93. So, this is the data rainfall दो अलग अलग places पे हुआ and we want to test कि इनमें there is a significant difference or not. अब इसमें टाइम सेम है तो डेटा जो है पेयर्ड है. अगर सपोज करो पहले वाले केस का होता 172.9 का और ये डेटा होता किसी दूसरे टाइम इंटरवल का, तो फिर हमारा ये डेटा पेयर्ड नहीं होता. पेयर्ड टी टेस्ट के लिए डेटा का पेयर्ड होना जरूरी है. ठीक है, द डेटा इज पेयर्ड एज विद कंपैरिजन ऑफ टाइम. सो वी अप्लाई पेयर टी टेस्ट. First we write the null hypothesis. The null hypothesis, as we know, there is no significant difference in the rainfall of two places A and B, or in mathematically we write it as H naught such that mean of rainfall in A place equal to the mean of rainfall in B place. We consider the mean of rainfall in A place equal to the mean of rainfall in B place. The alternate hypothesis, we consider there is a significant difference in the rainfall of the two places A and B. We consider that there is a significant difference in the rainfall of the two places A and B, or you write it as H A such that mu A is not equal to mu B. That means, there is a difference between the mean of rainfall in A place and mean of rainfall in B place. The third step is level of significance, and as we know in standard condition alpha is 5%, and if we need more precise result we take it as 1% or 0.1%. The next step for test statistic of t test is degree of freedom, and the degree of freedom is n minus 1, and as we have the sample size is 10 in. So, degree of freedom equal to 10 minus 1 equal to 9. Now, to find the value, to apply the t test, we first write the rainfall of first group, then we write the rainfall of second group, and we first of all find the difference between this paired data, or you can say pre and post values in another case. So, we find the difference x1 and x2 if it is x1. For example, this is x2, we find the difference between x1 and x2. So, we subtract 177.29 minus 0.6979, we find the difference of this and this, and it will be equal to for example 177.29, 69.79, 99 minus 0, 12 minus 75, this is 7, 6 minus 6 0 1. So, this is the value of first, we subtract the value x 2 from x 1. Now, we find the difference of this 42.19, 159.89 minus 74.29 equal to 85.60. For year 1974, we find the difference 111.68 minus 123.21, and this will be equal to minus 11.53. So, be here, look here, we are subtracting x1 x2, हमें x1 में से x2 को माइनस करना है. अब जब आपने यहाँ पर माइनस किया तो आपकी x1 की वैल्यू स्मॉलर है x2 से, तो अब आपको क्या करना है, हमेशा x1 से x2 को x1 से ही सब्ट्रैक्ट करना है. तो ये नहीं है कि अब यहाँ पर ये माइनस में आ रहा है तो आप x2 में से x1 को माइनस कर दें. ये सबसे मेन इंपॉर्टेंट पॉइंट है. आप हमेशा x1 से x2 माइनस कर रहे हैं, दिस इज x1 माइनस x2. तो आइदर x1 इज स्मॉलर और लार्जर, you always subtract x2 from x1. So, as here x1 is smaller, so it becomes negative. Now, in the second case 96.94 minus 91.47, it will be equal to 5.47. Similarly, 120.41 minus 68.18, it becomes 52.23 and so on. So, this is the difference. So, first we find the difference between the x1 and x2 and then find the total of this. You see in this case 90/80 also, the x1 is also smaller than x2. So, the difference is minus 2.42. To find the sum of these, we first add the plus terms, this and this and this, and then we subtract the sum of negative values. So, we first find the sum of positive values, then we find the sum of negative values, and then we add these. That means, we subtract the negative values from the plus values to find the sum. This will be equal to 382.93. In the second step, we square the d. In the second step, we square the d. D is the difference. So, 107.50 squaring will be equal to 11,556.25. So, next is 1,779.99 and so on, and we find the sum of d square. Look here, summation d square is the sum of the square of d values or difference. Summation d square means it is the sum of the square of differences, and this is 284.34.76 and summation d is 382.93. Now, we apply the t test. First, we find the d bar. D bar is the summation d. This d bar is the mean of difference, or you can say mean difference. D bar equal to summation d upon n, summation d, that is sum of the difference divided by n. This will be 382.92 divided by 10 and it will be 38.29. So, the mean of the difference d bar is 38.29. Now, we find the standard deviation for the difference values. So, this will be equal to summation d square minus summation d whole square divided by n. This is the sum of the square of the differences. The sum of the square of the differences is equal to 28,434.76. If you see in previous slide, the summation of d square is equal to 28,434.76 and this is the summation d, this is 382.93. So, we put the value of summation d square is 28,434.76 minus 382.93 whole square. I write here summation d square 284.34.76 minus sum of d and summation d 382.93 square upon 10 divided by 10 minus 1, this is square 10 minus 1. First you squaring the 382.93, it becomes 1,46,635.38 divided by 10 and it square root of 9. 9 means 10 minus 1. When we divide this value 1,46,635 by 10, it becomes 14,663.53 divided by 9. On solving this, we get standard deviation of the difference is 39.12. Now, we apply the t test formula. T is d bar, T is d bar s by root n, that is standard error. This is standard error, s by root n. D bar is the 38.29, standard deviation is 39.12 and n is the 10. So, it is root 10 because this also write it as like this. So, 10 क्या होगा, ऊपर चला जाएगा, रूट n ऊपर चला गया तो आपकी जो 10 की वैल्यू है वो ऊपर आ जाएगी. नाउ द रूट 10 इक्वल टू 3.16. So, t equal to 38.29 into root 10 value is 3.16 multiply by this divide by standard deviation 39.12 and t equal to 120.99 upon 39.12, and after solving this we get the value of t equal to 3.10. So, this is the calculated value of t. This is the calculated value of t. Now, for inference we compare this calculated value of t with the tabulated value of t. For degree of freedom 9 minus 1 and 5% level of significance, the tabulated value of t is 3.25. This is the tabulated value 3.25 and the calculated value is 3.10. Calculated value कौन सी है, जो हमने calculate की है 3.10. this ये हमारी calculated value है और tabulated जो हमें टेबल t distribution टेबल से मिलेगी. तो for t distribution टेबल में 1% लेवल ऑफ सिग्निफिकेंस 9 डिग्री ऑफ फ्रीडम के लिए t की वैल्यू जो है आपकी है 3.25. अब आप ये देखिए, वी सी हेयर आवर कैलकुलेटेड वैल्यू t 3.10 is less than the tabulated t 3.25 for 9 degree of freedom and 1% level of significance. So, since our calculated value t is less than the tabulated value of t, so we accept the null hypothesis, or you can say we reject the alternate hypothesis. Null hypothesis, we consider that there is no significant difference between the means of rainfall of place A and place B. As the null hypothesis, we consider difference is 0, that means the mean of rainfall in A place and mean of rainfall in B place have no difference. तो हमने ये कंसिडर किया था कि जो डिफरेंस है ए प्लेस पर रेनफॉल का और बी प्लेस पर रेनफॉल का, उसमें कोई सिग्निफिकेंट डिफरेंस नहीं है। ये हमारी नल हाइपोथेसिस थी। तो अब हमने नल हाइपोथेसिस को एक्सेप्ट किया। व्हाई वी एक्सेप्ट द नल हाइपोथेसिस? बिकॉज द कैलकुलेटेड वैल्यू टी इज लेस देन द टेबुलेटेड टी। सो वी एक्सेप्ट नल हाइपोथेसिस and we state that there is no significant difference in the rainfall of two places A and B at 0.01 or simply you can say 1% of level of probability. Next is, this is the T table to find the value of T for 9 degree of freedom at 1% of level. This is the value of T 3.250. Now, another term is least significant difference test. The least significant difference test is used in the context of analysis of variance when the F ratio suggests rejection of null hypothesis, that is when the difference between the population mean is significant. The test helps to identify the population whose means are statistically different. For example, the mean difference of pain reduction by 3 drugs A, B and C are significant. Then to identify which drug measure are significant, then we compare the A versus B group, B versus C group and A versus C group. अगर हमारे पास A, B, C 3 ग्रुप हैं, एनोवा से हमें ये मिलता है कि तीनों ग्रुप में एक सिग्निफिकेंट डिफरेंस है. सो फॉर फर्दर कंपेरिजन वी अप्लाई लीस्ट सिग्निफिकेंट डिफरेंस टू फाइंड विच वन इज बेटर. देन वी कंपेयर two groups at a time, A versus B, A versus C and B versus C. So, for this is the least significant difference test. Fisher gives the formula least significant difference test. The Fisher LSD increase the difference required to find a significant result, and here is the formula LSD is equal to T MSW up 1 upon N1 plus 1 upon N2, and the T calculated from the table for particular degree of freedom. N1 and N2 are the sample sizes for the first and second sample which want to compare. This is the formula for LSD. Thank you.